of your logging stuff and then calling back to the old method so that it gets all of its logging stuff done. And again, you could make this a sticky attribute just like protected public and private in Ruby by not having this switched off to false, so that if you say logged, then all the methods that appear under logged will become logged until you put another marker there that says, okay, turn off logging for all those methods. That's just another way of supplying a context. And this is very close to the actual language itself, because we're creating something that looks like language keywords here, logged and the acceptance test, acceptance only, but are actually just decorators for methods so that you can apply a context yourself for how you want those methods to execute. Okay, that's all I've got. The slides you can get from my website, and you can get the samples at GitHub. Does anybody have questions about any of this stuff? Because I've got a few minutes for questions, if anybody has any. Could it be that I've stunned you into silence? Questions? Yes?
What about exception handling? What if user uses such the DSL and he or she writes something illegal or wants to know what is really happening after executing DSL?
Yep. I think the best practice is to write an exception handling block that reformats their hard drive if that happens, and then by the time they get everything reinstalled, they'll have forgotten what they did, and they won't notice. No, that's not true at all. You can actually do syntax checking on internal DSLs. If you're curious about this, there's a guy named Jay Fields who has blogged a lot about doing DSL stuff in Ruby, and he actually has on his blog a syntax checker for one of these. Remember the one that I did that was the nutrition profile definition, that business natural language? You can syntax check that thing, basically by just evaling chunks of it as you get it. And he actually implemented, this is for client work, when he worked at ThoughtWorks, he actually implemented a thing that would do like little squiggly lines and other stuff to tell you that this is not syntactically correct yet until you got it syntactically correct. So that's one of the things you have to worry about, especially when you get into that spectrum of polishing, pre-processing, and parsing. Obviously parsing, there's a way around that because you actually have a parser, and you'll actually get a parser error. When you're doing polishing or pre-processing, you have to worry about that stuff yourself. So what you have to do is make sure you don't pass something to eval that it can't eval. So you can wrap that in an exception block and then figure out something to tell your user like, okay, I don't know what this is. And what you might start doing then, depending on how friendly you want it to be, say, okay, the whole thing we want eval, but let's take the first two the first two tokens in it and see does that eval correctly, and okay, then well the third one and so you can kind of build up and figure out kind of where it's breaking and then give a message back to them. But it's difficult. There's no easy way to do that, and it really depends on how polished you want your DSL to be as to how much effort you want to put into that. But it's mostly around the polishing and pre-processing that you have to worry about that. And of course, if you're building something like a business natural language, you can do syntax checking by just basically evaling chunks of it as you encounter them. But it's not trivial. Other questions about any of this stuff? Nope? Oh, yeah. It's a good question. What about DSLs in Python? The problem in Python is the white space. The significant white space in Python makes it really hard to write DSLs, which is a shame, because Python exhibits a lot of the same characteristics that Ruby. It's not quite as powerful as Ruby in that you can't really create new keywords, and there's some classes that can't be opened in Python, like object, which is a really handy one to be able to open. But the main headache is the white space, the significant white space, because it imposes a constraint on your DSL that you have to do indentation in a way that Python is okay with, which means that you can't really go nuts with the fluency of your DSL. There are a lot of dynamic languages that are pretty friendly for DSLs. Ruby, certainly, probably the friendliest one out there because the parser is so forgiving. You can also do it in Groovy, and of course, a lot of DSLs are written in Lisp if you can tolerate all the parentheses, but that's the problem there. And it's certainly possible, most of the building blocks are there in Python, but the white space thing is a killer for writing DSLs. So. Okay, well, looks like I'm about out of time, so thanks for coming and hope you enjoyed it.